Good afternoon, everybody. Going to get started here, despite no viewers just yet, but I want to get this one going so we can record it and get it ready for KeyCon coming up next week. All right, so let's get this guy out of the way here. So today's stream is going to be the new LiberArk68 that I have just finished. Got quite a few things to go over here. This is kind of my first attempt at a new layout for one of these boards, and I'm quite satisfied with it. This is built mainly with EZ-VIK wireless firmware in mind, and a lot of design choices have been made to make sure that this is viable and usable for mostly wireless setups. So this is mainly used with 2 halves and a dongle. So the dongle itself is, right now I'm using the Prospector style dongle, some of the newer screen bits on it, and I've been really enjoying it so far. Latency with the dongle is next to nothing, and the battery life has been excellent. I think I've been using it for like a week and a half, 2 weeks, and I don't think the battery has dipped under 80% so far with the, I think it's a 70-30-20 battery, so fairly small. This has also kind of been my first real big deep dive into full CAD design for a case, as I wanted it to have somewhat of a premium feel. So I've been kind of going to local keyboard meetups and just kind of looking at how other keyboards do their gasket mounting, and how they do everything, and looking at some of the cases that have been made by some of the more talented members of the community, and how they do their gasket mounting. So I decided that instead of having a plate that has the gasket mounting, I wanted to have the PCB itself gasket mount into a case. Hence why we have these wings here at the edges of the PCB. Those slot directly into the portion of the case that is kind of cut out for them, with some like neoprene or pour-on foam that allows it to kind of eat some of the harsher vibrations that you'd normally get with like a hard-mounted case, giving it a slightly more premium feel. It also allows it to just be a little bit more stable, since the plate isn't the thing that's holding up the PCB. The PCB is holding itself up in the case. And I think I did a pretty decent job designing a case for this one, where we didn't really waste a lot of space, and it actually feels fairly low profile. I do have a chalk version built. I will be building the MX version of it today to test out kind of the spacing that I've got for the MX case that I'm printing out tonight. But let me go grab the actual keyboard that's finished right now, and I will be right back. Okay, so this is the finished product for the chalk version of the case. As you can see, this is a 68-key keyboard with a very different setup, thumb cluster, and staggering wise from my typical Zodiark. Did a lot of workshopping with this, 3D printing out plates to make sure it felt good, and so far the experience has been pretty great with this one. I really like the swooped home row for the thumb keys and the kind of separated mod cluster down here for everything set up. I do retain some of the extra interior keys, so technically you do have the same amount of keys that you would have on, let's say, like the Zodiark, and the only thing that you're really missing on a stock build like this is something like encoders, but I did have it set up so that those could be easily added on. I am working on a second version of this case that kind of has a little bit of a offset with some heat inserts so that you can put a big plate up here that allows you to use our new VIK encoder slots. So I'll bring those out in just a second. I wanted to kind of disassemble one of these to show you the inner workings. Also, like I said, we are using a dongle, which is kind of the prospector style with the screen on it. This allows for point-to-point communication from both halves to the dongle, making sure that you don't have to waste time with Bluetooth processing using the proprietary Nordic, I think, Gazelle protocol instead of Bluetooth itself, which allows the keyboards themselves to be extremely energy efficient, great battery life, and lower latency overall. So when you do end up getting your order placed, I would definitely recommend getting a 3-pack of the Zhao Nordic MCUs. The 3-pack will give you one for each path and one for the dongle itself. Pop one of these guys open here. So I did make sure to design these with M3 hardware in mind. M2 screws are great, but I always strip them. Everybody knows always strips them. And when we're doing something with gasket mounting, sometimes magnets are just not strong enough to really keep the whole case together. It's okay when it's on your desk and you're not really moving it around, but if you're ever traveling or bringing your keyboard anywhere, they do tend to fall apart if you use magnets. So I went with M3 screws for the full case. As you can see here, like I said, it's fairly low profile. I did manage to shave off a lot, adding some holes at the bottom so you could kind of use double-sided tape to attach the battery to the bottom of the board. And then if you've got feet on it, it is definitely clearing the bottom and is quite stable on your desk. Let me get this pulled up here. All 3D printing files are getting uploaded tonight. I am hopefully going to be getting kits ready for sale within the next few days. Hopefully, not hopefully, I will have them live by KeyCon on Saturday. This does use heat inserts, and it uses either 5 or 6 millimeter M3 hardware for the screws. Oh, come on, I believe in you. I have been making full use of my new multicolor printer. I got a Snapmaker U1, so I can add these fun, fancy designs to the back of the keyboard. There's that one right there. Hopefully to have these available for purchase as well, along with the keyboard, kind of to print it to order. So definitely gonna have some sort of lead time on that. All right, so let's get this one out of the way here. All right, so here we are. This is the fully done chalk version of the PCB itself. Just kind of go over a bit of the features here. As you can see, I do have a nice clear space right here for the actual battery. That is just using just double-sided duct tape to hold it to the board itself. With a standard 2mm connector. I know that some of my other builds have used much smaller ones. I wanted to make sure to use one that was, you know, an easier to get around size. As you can see, it is Hotswap. No LEDs on this. That was kind of a decision made to make sure that we're not going to be wasting a ton of energy on LEDs, and making sure that you have good battery life. So that was one omission that I made compared to most of the other keyboards that I've designed in the past. It does still have full VIK connectivity, and the reason I was able to do that with such a small microcontroller is by adding on shift registers. So these two shift registers allow me to create a bunch of extra pins for columns. So the matrix is a little goofy in comparison to something like a Zodiac, where you've got, you know, column, 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 row, 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 each one. This one's more of there's 3 large rows and a bunch of tinier columns, since we have all these extra pins. And that freed up a bunch of pins on the actual MCU itself so that I could feed it to the VIK connector so that we could have more add-ons. And beyond that, just you've got your on and off switch over here as well, so that you can, you know, fully turn it off. It does support sleep modes. Typically it falls asleep after about 5 minutes of no activity and wakes up after you press a key for the first time. So pretty easy build, to be completely honest. The only part that's a little difficult is we do have a few extra pins on the back. I'll get this up into the camera. We do have a few extra pins on the back of the Zal microcontroller that we wanted to get access to. 2 pins down here are used for the extra GPIO pins for the VIK connector. You've got your battery plus pin, which is required, and then another pin over here for the reset. There is a reset button on the Zao itself. It's just extremely tiny and very close to the USB-C over here. So I wanted to make sure to add a larger one that we have access to, since usually people hang on to these boards for quite a while. And as you can see, the case here, we are just using some pretty generic 4 to 3mm Poron strips for the gasket itself, and then those sandwich the wings of the PCB in the case itself. It is a pretty neat solution, and I'm pretty happy with myself with how it turned out. I'm definitely doing a lot more modifications right now for add-ons to make more use of kind of this dead space over here and kind of expand that out so that we can add encoders and touchpads and things of that nature. And that is a work in progress, but as it is right now, this keyboard is fully functional with all of the keys and just kind of as is with the dongle. So pretty fun setup there. Just gotta put this back together a little bit before we can get started. I'm not gonna do all the screws, just a few so it doesn't fall apart. Oh, that is not connecting. There we go. Okay, that should be enough. I did actually just get switches in for these new roller encoders I am trying to set up. They are the 3D printed ones that are the same ones on the Zodify, where you use a mouse encoder hooked up to a 3D printed wheel to create your own roller encoder. I'm doing this because the Panasonic roller coders have just absolutely blown up in price. They were a limited run. and they were discontinued by the time that the keyboard community got their eyes on them. And once everybody started including a footprint form on their boards, supply ran out pretty quick. So I just wanted to make sure that we had an option where you could just kind of make your own roller encoder, just because people know that they like the mouse style, the wheel style a bit more than the circular rotating one. There are also VIK modules available that do the regular encoders as well, so those are always an option too. All right, getting this all pulled up here. Oh, interesting news. I know what I'm doing after this. Just got news that a game I've been waiting for is released. Yeah, EXO Rally Championship from the makers of EXO 1. Quite an interesting game where you're a rally racer, but on different planets. It is a very interesting setup. All right, cool. So we got this all ready to go. Like I said before, this is not necessarily a very difficult build. Since I've omitted LEDs, there's not a lot to really solder when it comes to the really, really small piddly stuff, such as mainly the LEDs themselves. So normally these you would have 4 legs and then 4 pads that you would have to do for each one of these for each key. Since you don't really have to do this build actually goes pretty dang quick. So let me just start getting stuff ready here. I'm just going to do a brief overview of kind of the build process. As with most boards, I usually start off with the diodes. Let me actually just do one at a time here, and I'm going to actually pull us in so that we can see the whole enchilada here. All right, let's get this framed up pretty well here. That's a little too far. Okay, cool. So first time you want to build one of these, I definitely recommend starting off with your diodes. The diodes are kind of the smallest bit and can kind of be overshadowed by larger pieces of parts that you would be putting on later. Once those are done, usually I move on to the Hotswap sockets. This one supports Chalk V2, which use the same Hotswap sockets, but it does require a different center hole and an extra hole over here for extra pins that they typically have. And I think it's like KS33, the Gatoron low profile. I have not gotten any of those Hotswap sockets in yet, so I have not been able to test those. But the footprint is known to support them and everything is wired up correctly, so should work, no problem. From there, typically I would, just to finish up all of the back, actually no, that wouldn't be much of a good idea. You'd probably want to flip it over at that point. And you would want to install both of your through-hole shift registers. And then also most likely you'd want to put your switch on. And, you know, also not probably a bad idea to add the ZOW at that point in time. And then we'd flip back, we'd probably add the battery connector, and then add our EZ-VIK over here as well. That's just a separate daughter board. And then we do have 2 spots for decoupling capacitor, 100 nanofarad, so that the shift registers work correctly. I'm just going to do 1/2 for today, just to get through the build itself quickly. Yeah, looks like we should be good to go. Okay, so as I said, let's just start off with the diodes real quick. Got these right here. Just going to open up the strip real quick, kind of taking a we go. Nope, that did not get underneath them. These can be a little temperamental. Let's start from the other side here real quick. Sometimes it helps to get a little pinch and it gives you a little opening there. Perfect. And just kind of... get in there and run that through. Oh, I lost a couple, but that's not a problem. And there we go. Okay, there we go. Got all of our diodes. Gonna just put those off to the side here. Just as a reminder, the diodes are directional. So you do want to make sure that with the diodes, you do want to match up the arrow and the large white line with the line on the diode itself. I'll get close up here to give you a good example of what that looks like. Just one moment. I do have a new camera, which I do like quite a bit. Let's see, are you going to focus that close? Maybe need to pull you up just a little bit. There we go. Yeah, no, that's a great view right there. Okay, cool. So as you can see, with the diodes, you do have the symbol, which is the arrow pointing to the line right there. That is going to coincide with the line on the diode itself. This is upside down from the text perspective. It does say T4 on there, but as you can see, the line is on the right, and the line over here is pointing over here to the line. I also added a large white bump out over here next to the pin that you would want closest to the line. So typically with those, you'll just get in there and place it on there. After soldering a little bit of solder on the left side, reflowing the solder and just kind of shoving it over, letting it solidify, and then letting it go. So let's do that real quick, just to kind of give you a very close-up look at that. Just letting my soldering iron heat up here. Typically for this type of work, I'm usually on my Pinesol up at around, I'd say, about 130 degrees, or 330 degrees Celsius. Here, let me just pull out for just a second here. So yeah, around 200 or 330 degrees for soldering these. Let's get back down here. Okay. All right, so like I said, first things first, we're just going to take the left pad and apply a blob of solder to that. Quite simple. All right, there we go. We got a nice, beautiful ball of solder there. Just as a heads up, I do use Kester leaded solder for this. A lot of people would probably recommend using non-leaded solder, but that is a personal choice of mine. It just works better, especially for these builds. The boards are usually non-leaded solder, but I mean, unless you're really crazy about making sure that you don't contaminate like soldering iron tips or something like that, it's usually not really a problem. So let's get this pulled up here. So next step would be to take and orient your diode to correctly match up with the lining. And as you can see, we have the line on the right side to match up with the pad that has the line next to it. So what we're going to do is just bring our soldering iron in. We're going to reflow that little blob right there, and then move the diode in, remove the soldering iron, and then once it solidifies, you should be able to jiggle it around and it won't move. At this point, I would just go through and do all of them this way, and then once you're done with all of these, I would just come back in and do the other side to make the full connection. All right, and there we go. We have a diode installed. All right. Let's pull back out here. Do have my fume extractor right here. I'm going to move that out of shot. Okay, I'm going to move this a little bit more forward here. Okay, cool. So that is the pretty easy way of doing the diodes here. I'm going to just go through and tack down all of the diodes real quick here by soldering up the right pad. I did do the left on this one. That was more for kind of showing the line on the diode itself easily. But I'm going to do the right side on this one so I can just keep the soldering iron in my right hand and bring the diode in from the left. I think one thing I did forget to mention is that I would also, while you're down here, take care of the reset button as well. Do note there are a couple, or actually just one diode that is not in the same position as the others, just because I had to move it up to the top right side or top left side of the footprint to make room for the battery connector. So just don't forget that one. Wouldn't want to get fully built and realize a key isn't working. I got a new camera and a new microphone set up, so hopefully these look and sound a little bit better than my older videos. I knew the sound was a little difficult, got a little echoey and weird just because of the kind of room I'm in. But right now I'm using kind of like a clip-on, like Instagram reel maker style microphone, so seems to be working out a lot better. Okay, I think I've padded all the tins here, or tinned all the pads here. So now I just got to go through, make sure all of my diodes are lined up correctly here, and just start installing them. And I'll start top to bottom here. Any better tweezers for this? I think I do, actually. I do like the angled angled tweezers a little bit better for this. Lets me get a little more control over it. Mainly because you can keep your hand a little bit off the table while you're doing it. Uh-oh, lost that one. Come back to me. All right, tacked most of those down. Let's just take a quick look here, make sure that we didn't miss any real quick. Got all those, all these. Didn't miss that guy right there. Yeah, looking good. So at this point, typically I will flip the board itself and just kind of come back in and tack down the other side of each diode. I'll start up top here. No, that one already did, so oops, just got a little extra on there. Normally I let a little bit of solder build up, so it kind of has like a potting effect, but after there's so much, I usually clean off the tip. You just want to make sure that you see soldering cover the entire pad and the pin itself, and has a nice little smooth bit to it. If it looks like a ball, it may not have flowed all the way through to get to both the... oh, did this thing die? Uh-oh. Guess the accelerometer wasn't working. Come on. There we go, now it's warm enough. There we go. All right, gotta get some more solder here before I burn my fingers. So if you want to know what solder I use, it is the SN63PB37. This has kind of been my favorite leaded rosin core solder that I've used. I do have to say that a pound of this stuff is definitely doesn't cost what it used to cost. It is very expensive now. I do have some no-clean solder from Kester. It just definitely does not work as well, oddly enough. I'm gonna have to start looking into other solders here, see if there's anything cheaper. I mean, I doubt it. Everything's expensive these days. All right. I think I might actually just move on and do the two tiny little guys here. Got a couple of those. The capacitors for the shift registers. All right, cool. So these guys don't have any polarization. You just put them on as they fall. Just do be sure to make sure A, you've got a good connection, and B, you don't use too much solder and accidentally bridge these. Otherwise, you will cause a short on the actual board itself, and that could cause quite a few problems. So let's get those put together here. So just like I did with the other one, I'm going to tin one side, typically the right side, so I can just keep the iron in that hand. All right. And then just grab the capacitor. Make sure you just drop it on the board there to make sure it's nice and flat. And then while reheating the solder up, you just kind of reintroduce the cap itself and make sure that the solder flows to it. Pretty easy. Well, do the other one. I can do a close-up real quick of that. There we go. Oh, where did my... There it is. Okay. Get you centered up there. All right. Like I said, usually I just drop it on the board itself to make sure it's actually flat and perpendicular to the board itself. Then I grab it, introduce my soldering iron, flow the solder, and just bring the cap in. And as you can see, it kind of forms a little hump over to the actual top of the cap itself. That's how you know it's flowed correctly. And then we'll flip this guy over and just do the other side real quick. There we go. Let's do the next one as well. All right, and that's all of our capacitors. Only 2 on this one. Normally there would be about 5 or 6 or so, but since this doesn't have LEDs, we don't really need those decoupling capacitors as much. We just need 1 for each one of these shift registers. All right, let's zoom back out here. Get you in a same position, and yeah. Oh, nope, I wanted that a little bit angled. Okay. All right, we're back to the full view here. Okay, so next step is going to be your Hotswap sockets. Those are going to be the large pieces that allow you to put your key switches in without permanently attaching them to the board. So I need quite a few of them. I do have them on the reel. Please ignore the noise here. Just gotta cut off a chunk of them. So with the Hotswap sockets, normally I will just pre-place like a row of them or a column of them and then solder them in one by one on one side and then flip it over and then do the other side. So just going to dump a whole lot of these on here. There we go. That is a whole lot of them. Put that in the trash. Get them all off the board itself here. All right, so pretty easy here. This is a bit of a Swiss cheese mess for the footprints. But they're not that terrible. As long as you keep the top of the actual Hotswap socket perpendicular, you should be fine. So I'm just going to zoom in on this one in the corner. Oop, 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 come back to me. Okay. All right, so typically you're just going to kind of find your bearings here. This one over here, I do have the outline kind of matching what an MX would look like when you place it on there. So as you can see, just kind of drops in right there. There are predefined holes for it. Yeah, no, that's nice and in there. So these newer style ones, you can tell that they used to have this little tab not on there, and it would just be kind of a U shape. Now it's kind of the U with this little guy sticking out. Makes it a little harder to solder them, but as long as you take your soldering iron and touch the soldering iron to both the pad that you're soldering to and the actual wing itself on the Hotswap socket, give it a couple seconds. That'll preheat everything, and then you just introduce your solder, and you should see it kind of flow on to both. And then normally I'll just take my finger and hold down the hot swap socket, let go. As you can see, you got that kind of swooping effect going all around it. So that means that it's flowed on both the pad itself and the actual wing. So when you do put your finger down to hold it in place while the solder kind of coalesces, make sure you're putting your finger off to the side so that you're not touching the rest of this metal part and burning your finger. I've done that several times. It's not fun. So pretty simple, large soldering here. So let's get you zoomed back out. There we go. Okay, cool. So I'm just going to start placing these all in here, one by one. It is a little bit more difficult than some of the other ones, since it is a very holy footprint. Also, something to note is technically you could accidentally install one of these facing the wrong way. So normally the way you want it is that this divot is going around the center post hole. If you do it upside down, so I'm going to do an example here, you can install it that way. But as you can see, you are blocking the center post hole. So when you go to put a key switch in here, there is a large peg that fits through here, and it will just ram up against the body of the hot swap socket, which isn't good. That's a good way to rip off pads and destroy your very expensive and time-consuming project. So just want to make sure that when you're installing, especially the MX hot swap sockets, that they are oriented the correct direction. Now, with the chalk hot swap sockets, you don't really have to worry about them because they are pretty much mirrored. As you can see, they kind of have this this dog bone shape to them, so they are technically mirrored in that manner. So you would kind of place them like this, and if you flipped them over, it's the exact same. If I can get it to cooperate, of course. Yeah, so you don't really have to worry about that with the chalk hot swap sockets, but for the MX style hot swap sockets, do be very careful to orient them the correct direction. That didn't go in correctly. There we go. Oop, oop, oop. Okay, those are all prepped here. All right, gonna just tack each one down on the right side real quick. There we go. Give myself a little more space here. All right, here we go. Sometimes for these Hotswap sockets, I will kind of boost the heat up a bit since I am dumping a ton of solder into them. So usually I'll go up to like 360, 370, just to kind of make this a little quicker. As this does not have any very sensitive components on it, such as LEDs, you can typically run your soldering iron a little hotter. Whereas if you were building one that does have some sensitive electronics, LEDs being the main culprit, you typically want to run your soldering iron a little bit lower, typically in the 290 to 300 degree range, so that you don't risk delaminating or undoing the internal soldering for the chip inside of those LEDs. But don't have to really worry about that here. So you can run a little bit hotter to make things a little bit easier on yourself. Some of these do get a little close due to the staggering. You just have to kind of angle your iron to get in there right. And I'll do the nice little drop trick to just finish this one up. Oh, and there we go. Time for more solder already. I do really enjoy my Pine-Sol V2 here. Still have my V1 as well, but it has been relegated to heat set insert duty. I'm actually thinking about getting one of the kits where this is on kind of like an arm so that it stays perpendicular to your work surface, so you get a perfect fit every time. That depends on how many 3D printed cases I end up selling, because that would definitely make sense to buy if I was selling quite a few of those. Otherwise, eyeballing it does just as well for a few of them. All right. All right, let's flip her over. And then you don't really have to hold them down this time around, so just kind of go to town. Do note that when you get to this half, due to having to have pads for multiple different types of hot swap sockets, that the pad is much larger, so you may end up dumping a bit more solder than you're used to for the other side. So just keep that in mind. I typically just like to keep the heat as close to both the pad and the wing itself, or the portion of the pad closest to the wing, so that it does still go through. So there you go. Sometimes to make sure that it's melting into the actual hot swap socket itself, I will put the solder itself like directly where the edge of the pad and the wing itself kind of meet over on the side instead of like up in the front, just to make sure that I know that both were hot enough to bring solder in. Yeah, as you can see, that's kind of not swooped up into the actual hot swap socket itself. So you want to just make sure you get in there, get enough heat, and add a little bit more solder, because the solder itself has the flux in it. And there we go. Now it's kind of swooping up into the hot swap socket itself. These hot swap sockets are the reason why I go through so much freaking solder. Because they definitely require quite a bit. And you don't really want to skimp on it, because it gives it a more stable connection to the board so that it doesn't end up like ripping itself off the board or ripping the pads off the board if there is a bit of a collision. Let's say like the pins on your switches aren't necessarily fully aligned. So more the merrier when it comes to these hot swap sockets, in my personal opinion. I mean, you still are definitely limited by the strength of how the hot swap socket pad itself is kind of like epoxied in, or the epoxy layer of the PCB itself. Now, from a design perspective, that can kind of be avoided by adding some vias kind of in the pad itself. However, that does make it a little bit harder to solder on as well, just due to the fact that the vias themselves will eat up, kind of suck in some of your solder. So if you were doing this for designing it for being assembled by like an assembly line or like a fab or anything like that, where they were using like a pick and place machine to place each one of these and then kind of just running it through like a solder paste and like a oven, basically. The vias in the pad itself, the little holes that would connect one end of the board to the other, would kind of leach some of that solder in. And since they don't really use these huge blobs of solder, the vias in the pads can cause a lot of problems, incomplete connections and things like that. But for somebody soldering it by hand that's dumping a ton of solder in there and has like an eye for each single component that they're installing, well, that's not really much of a problem. And I do have a couple vias in these pads. Not a whole ton of them, just because if you do start adding a ton, it can start becoming a problem for people who are hand soldering, but yeah. Just kind of straddling the middle of the road there. All right. Almost to the fun part, which would be the shift registers and the microcontroller itself. I'm going to hit that one again. That one didn't look quite right. Okay, yeah, that looks fine now. Okay, cool. So we are we're looking pretty good. Those are all the Hotswap sockets on there. Let's just do the reset button next real quick. Got a new style of reset button that are pretty low profile. Nice little clicky ones here. Just zoom in real quick. All right, maybe pull it back just a smidge. Yeah, there we go, that looks good. So, bring this guy in with some tweezers. So got these new, smaller, low-profile reset switches. They give a nice little satisfying click and don't take up a ton of vertical space here. So for case design, it was really helpful. So just kind of install this like I would a diode. Just take one of the pads of the 4 legs here, and I'm gonna fill that with solder. And just take the button itself and make sure to drop it on the board so it's perpendicular, and just slide it into that reflowed ball of solder. Just make sure you're lined up on all the other legs so that you can solder it into the pads itself. Too far, too far. There we go, awesome. Okay, cool. So we got that one right there. Let's get the one below it real quick. Awesome. Flip this board around real quick. And there we go. Okay. That's good. And that's good. Okay, cool. Reset button is done. All right, that kind of takes care of most of the stuff on the back. I'm going to save the VIK connector for last, just because that's kind of a bigger one here. But now let's flip her over. The one part that we do have to solder, the 2 parts we have to solder, are the MCU and the reset, or the power button, power switch. So let's do the power switch first, just because that won't be tall enough to interfere with us seating the shift registers. So I do have these kind of in a reel here. Just be chopping the reel up and putting a couple in each kit. And so just want to get one of these out real quick here. Boosh. Okay, so these are a little tiny. So you definitely want to be careful and not kind of overdo the amount of solder you put on here. And there are quite a few pins. So as you can see, you've got these wings right here and these wings right here. Those are just mounting. They aren't like electrically connected to anything. Here, let's get a zoom in on that real quick. All right. Okay, cool. As you can see though, there are a couple holes right here. Those holes line up with some holes in the actual bottom of the switch itself. To kind of keep it in place while you're soldering it down. So they're not that bad from that aspect. So normally what I do is just get it in there and it sits perfectly flush. Now, the one thing I will say is that the whole body of this is metal, and that is connected to the actual mounting wings itself. So if you stay on it too long and you're holding it down with your finger, you can definitely burn your finger. So just be careful about that. But we're just gonna do it one at a time here. So I'm gonna do that top right wing first. Kind of get a little bit in there, press it down a little bit. Ah, okay, yep, did the exact thing I said I was going to do, and kind of burnt my finger a little bit. So now that we have that one just kind of ready, maybe we should do it like we would do a diode, where we've got the one wing tend. We bring in our switch. Let's make sure we're holding it right there, and then we reflow. And then let it kind of sit itself down. There we go. Now that's on there, and now you don't have to touch the top. Let's get the wing below it. Okay. These three down here are the actual electrical connections to the battery. So do one at a time here. So 1 and a 2. And a 3. Excellent. And then I'm just going to turn it around. Woo. And take care of those last 2 wings. All right, awesome. Now let's get this pulled over. So next up is going to be the 2 dip package, oh, there they are, shift registers. The only thing I will say is that the shift registers, since they are indeed dip packages, the legs themselves can get a little bent out of shape. So I would definitely recommend going through and trying to straighten any legs that you see that are kind of egregiously crooked. One second here. All right, so just taking a look at these legs, they are slightly crooked here. So I'm just going to take this guy and make sure I get this bent back into place. Probably would help if I zoom out a little bit. Take my tweezers here and just kind of bend the actual main body portion a little bit. Get that in line with the rest of them. Take this guy, move that back up. Twist it back straightish. Overcorrected. That looks pretty good to me. And just kind of make sure that they're all kind of lined up from front to back. This one's not too bad. This side, I just probably need to get this guy back in line. Okay, yeah, that should do the trick. As you can see here, I do have kind of an outline for the dip over here. Oh, we got spam in chat. All right. So the outline here with the dot lines up with the notch over here and the dot over there. Don't be confused by this dot at the bottom. Let's get a zoom in here real quick. I swear for build streams, I should be getting like white PCBs instead of black, just to make these a bit more apparent. So as you can see here, you've got this little notch right here in the top. That notch is going to line up with the dot up here. They also have the dot off to the side, kind of the dished one right here. That's also indicative of the orientation. The only thing that sucks is that it does have a giant like dot down here as well, which can be confusing. So you're always looking for the notch. The notch lines up with the dot up top. So normally I'll get one side in, kind of make sure it's bumped up, and then just kind of use my finger, if I can get a better angle on this, use my finger to slowly kind of bump these into their respective holes. I think you're like the only one left, yeah? Okay, and then, maybe not. Ugh. Oh, yep, that one's out of place now. And boom, there we go. That's in place. And then just rinse and repeat for the next one here. Let's get you back up in normal. Just getting this one kind of lined back up. This one was actually fairly straight to begin with, so don't foresee many problems with this one. So let's just do the same thing here. Just kind of line one up. That side of the left side went in this time. So now I'm just going to kind of finagle it so that I start getting these in the holes one by one, and boom, that's seated. Those are on there. And being dip packages, they do look pretty cool. Very old school. Now, just to kind of make things easier, since I didn't install this is nice because it'll sit nice and flush. To make soldering these down easier, typically I'll just kind of go through and just knock down each one of these pins over so that it doesn't accidentally come up. You can use a fingernail, or you can just use like tweezers or something. I'm sure most old heads will say that this is silly and pointless, but I don't care. I like the way it looks, and keeps me from worrying about dumping them out of the board if I do turn it over to look at something. Plus, if you do it this way, you don't have to come back and clip every single one of these to prevent anything from like getting poked on. Personal preference, this is definitely an optional step for most people. All right, cool. Now we're ready to solder these down. Pretty simple, no real technique needed to that. Just get your soldering iron warm and get some solder on there. I did think that maybe we'd want to turn the temperature back down to somewhere around like 330, 340, just to prevent any problems. While I was designing this, I did ask somebody, or somebody did ask why I didn't just do the like the 8 dip like Hotswap sockets, and mainly just so I didn't have to worry about the extra overhead for A, parts cost, and B, the literal height of them on the top of there. Since I did want to make sure that the case itself was pretty easily printable, and if I had add another like 3-4 millimeters of height, it might make things a little awkward from both a design and like a aesthetics perspective. All right. Awesome. Okay, we're most of the way there. I'm going to flip this back over here, and the most important part I'm going to install is the MCU itself. So, if it'll come out here for me. Come on, don't be shy. There we go. Okay. So as you can see here, we are using the Seed Studio ZAO NRF 52840. Pretty ubiquitous, easy to get a hold of. I typically purchase the 3 packs off the Seed website, and they ship from the US. They also have warehouses in the EU, and you can just get them directly from China if they're out of stock in those places. Pretty similar to some of the other ones I'm doing here. Usually what I'll do is I'll kind of solder, put a blob there on that top right pad, and then just kind of slide this in over while it's liquefied, and just line it up so that all of the holes are lined up with the pads on the board itself. So pretty easy, pretty quick. Let's just get in here. So nice, large amount of solder there. Let's get our board, plop it on there. Then I typically grab it by the shield and just slowly heat the pad up so that that solder liquefies, and just kind of move it over. Hold the soldering iron directly to the pad so you can actually heat it up and the solder will flow up in there. And at that point, it's on there. Now, I'm not going to say that this is completely straight, so let's kind of get in there a little more. And you can adjust it by just slowly applying some more heat to it. All right, and then shifting it about where you would want it, which that's a little high, I think. No, maybe I just have a bad perspective. Oh yeah, that's dead on. Okay, excellent. From there, just kind of come through and take care of the rest of these pads. Like I said, just make sure you're holding the soldering iron, making contact with the pad on the ZAO itself and the pad on the board, and that should flow together nicely. Add a little bit more solder to this just to kind of get some flux. Yeah, that's a good one. All right, one side done there. Just gonna flip it around. Gonna need a bit of new solder so I don't burn my fingers. Let's get a nice angle here for you. That's kind of the benefit of this new webcam, is I can kind of get it real close in there and give you some better angles on what I'm actually doing, give you some better context. All right, grabbing the solder right now. All right, start with this one over here. Oh, didn't get on the pad itself. There we go. Yep, seem to be coming in contact with the actual camera itself. Don't want that happening. Now you can see kind of like how it bridges from the pad itself up to the pad on the ZOW. Quarters get a little tight when you're close to the switch itself, but I'd rather be dealing with these large pads on the ZOW right now than those tiny pads on the actual battery switch. Okay, let's get a good angle on this here. As you can see, those are all nice and bridged to the pads on both the board and the ZOW. Okay, let's get you back out here. Okay, cool. All right. Now, the most difficult part is these little pads here. So what I typically do is I grab either like diode legs, or in this case, I'm just going to be using a resistor. And this is a little bit fiddly work, but let's get you in here. What I'm typically going to do is I'm going to tin the pads on the ZOW itself. Can be a little difficult because they are recessed by about 1.5 millimeters since they're on the back end of the board. But as you can see, it's pretty clearly labeled which goes to which. You'll see, you know, battery plus pad, and I've got a little arrow pointing to which one is the battery plus, the other one is the ground. Got the reset button. It's this one right here underneath the USB port. So not too terrible. So let's get these tinned real quick. And approach of angle is important here. So always kind of reconsider your angle if you're having problems. And, you know, your choice of soldering iron tip does help too. I think a chisel tip might be a better selection for this one, but as you can see, it is working. Make sure these two right here are fairly important. That top one's ground and the bottom one is battery plus. Make sure we're not bridging these two. We're already getting ground from one of the pads on the other side, so I don't worry about getting the ground down here. We're only worried about the positive battery terminal down here. Flip this over so I can see angles fun there. Add some more. There we go. And then this little dot right here is the next one. That one was easy. Okay. So next up, the way that I typically do it is, let me just flip this around real quick, make things a little easier. I'm just going to approach real quick with the whole resistor, not even going to clip it yet, just so I have more to work with. Just going to come in here and tack this down onto this pad right here. So all you got to do is get the pad heated up, pull it in, and then just make sure it doesn't move too much after you pull it off so you get a good connection. Give it a couple tugs. And that does look pretty good. And it's a little messy. I'm going to try to float again and see if it looks a little bit better here. I think that's about as good as we're going to get. At this point, I'm going to flatten that onto the pad itself. And give it a little kink right there. Perfect. Okay. Awesome. Now I'm just going to come in and solder that portion of it down to the pad itself. And there we go. So from here, what I'll do is just pull this up and pull in with some little snippers and snip off the excess. And boom, there we go. We've made a connection. I'm just going to repeat this with this resistor as many times as I can. So taking the rest of that end of the resistor, flipping it over. I'm going to merge it with this right here. All right, that's nice and in there. Just going to move this over. Make sure I'm not bridging anything. Just flatten it with my fingernail there. And rinse and repeat. right. Boom, done. And yeah, I think that one's a little too short to continue using, so all I'm gonna do is flip it over. So now let's flip this back over since we're gonna be approaching from the other angle. Just gonna get in here, flow the solder to the battery positive, make sure it flows onto the actual pin itself. Yeah, that's nice and in there. Then just flatten that on the pad. Bring in the solder. And give it the snip. And then for the final one, the reset button. Here, I'll get in a little closer for this one here. All right, so just gonna take the tip of that resistor, just flow that onto it, give that a couple tugs, that's on there. So flatten that down onto the pad itself. And solder it down. Just lift that resistor up. Give it a snip. Yeah, and this can be a resistor, a diode, any through-hole, long-legged piece of equipment there that you have, or component that you have. All right. I mean, like I said, I would consider that the hardest part of this build is getting those extra pads taken care of. I mean, technically the only one that's required would be the battery plus, but if you were going to be adding any VIK modules, you would need these two over here. And if you want to be able to use the reset button on the bottom of the board instead of pressing the super tiny one on the ZOW itself on the top, you'd want to do that. So at this point, we really only have, let's see, one piece left, and that is the EZ-VIK. So these usually will be included with the kit. These are the breakout boards for the VIK connector, so that you don't have to solder on 0.5 millimeter pitch flexible cable connectors. Instead, you got these nice big chunky pads. And the other benefit of having the nice big chunky pads is that if you do have something that you can't quite adapt into the VIK style ribbon connector, you can just run wires directly to these. And if you take a quick look, I do have labels for all of the pinouts. So as you can see here on the bottom, you start off with your 3.5 volt ground, your SDA and SCL for I2C. On the left side at the bottom, you've got the red, green, blue. You got your 5 volt, your first general purpose input-output pin. On top of that, you have your SPI, your COPI, controller in, or controller out, peripheral in. And then at the top here, you've got your GP2, which is your general purpose input-output second pin. You've got your CS, your chip select for SPI, your CIPO for SPI, which is your controller in, peripheral out, and then your SCLK, which is like your sync clock for SPI. So all of those are broken out there, so you have a lot of options on everything that you can add on to these boards, as long as it's supported by ZMK and is able to take 3.5 volts, since that's typically what's provided by the ZOW in wireless scenarios. Also recommended that you do keep an eye out for the power consumption of anything that you're adding to this board, because it can dramatically affect your battery life on these. Currently, I feel like I might be able to get a month or more off of this board with the standard battery. The power draw on this with the dongle is pretty great, since it doesn't really have to do any of the management of talking to the PC. It just has to send its states over. So I will be trying to add one of the AZOTech touchpads for multi-touch and see how that works out. Something like, this is one I took off of another build, but this guy right here, very large multi-point touchpad. We'll see how that works out. I'll get back to you on that once I figure that out. I am designing a mount for this for the case itself, the separate version that has the additional plate that you can add additional items onto. So put that back. All right, so snipped this one up so that it's nice and flat there. So just like I did with the Zao, just going to take a corner and tin it, and then kind of move this in and jostle it until it is lined up. So let's bring you close into the action here. Trying to get you so you're not getting a glare, and I also have access. Oh, that's coming loose. Tighten the gantry up on this a bit. Okay, cool. So it's going to take that top right pad. There we go. Just going to grab it with the tweezers by the actual flex connector itself, just so I can get it nice and flat on there. And going to liquefy that solder, drag that in, line everything up. And that's on there. And looking for my angle, yeah, that looks pretty good. So I'm just going to take care of the rest of these pads. Same concept here, just make sure that you are contacting with your soldering iron both the pad on the board and the pad on the EZ-VIK connector. Get a nice positive connection there. Let's give this a good turn. Oop, hitting the camera there, sorry about that. All right, it's looking nice and shiny on my side. Okay. All right, cool. Let's get you back up to the regular view here. All right, so that is one half of this 100% completed. As you can see, we're ready to put on any kind of MX switches. I got some right here just to kind of give an example. All you would want to do is make sure that you're aligning these side pegs up, and boom, there you go. That's nice and installed. Pick up the whole board by it too. So pretty stable. I do also have a 3D printable plate. The cool thing about the plate is that it just sits on there. You don't have to worry about it. You can take the whole PCB out and still have the plate attached to the PCB, since the PCB isn't really used to mount the brains of it into the case itself, since it's got these wings here that are interfacing with the case. So yeah, that's one half done here. Let's just give it a one good look. Eventually, for the additional modules, I do have the I do have a breakout on those. Here we go. Actually, they're right here. The additional VIK modules. These will allow you to install the mouse encoder and a 7mm micro switch, and then add the 3D printed parts to make the roller encoder. It does have the VIC connector here. I left them unpopulated for the first couple of runs because with this particular case, I do have the 5-pin breakout up here. Since the VIC connector would only really be providing the 2 pins in the ground for the roller portion, but the column in the row would not be included. So I have those broken out so that you can just run wires into the extra pins I have laid out over here. So I've got row 1, 0, and 2, and then all the extra columns. There are a couple columns that just don't have rows attached, so you would be attaching them over here. I'll have a wiring guide once I get this all kind of figured out on my end. And then the idea would be to move the E1 and the E0 to the GPIO pins. I think with ZMK, I was looking into it, it may be able to share a single GPIO pin between 2 separate encoders per side, so that you could run 4 encoders total. If that works in firmware, I'm not 100% sure yet. So that'll be a separate video once I got that working. All right, cool. So that's 1/2 done. Pull that out. Got some Zelios clickies on standby for this one. I just got to pull them out of another board. Not sure what keycaps I'll put on this one though, but we'll see here soon. All right, so got all that going. I think I've got enough time now just to kind of do the other one real quick, so that we don't have to wait on that. I'm just gonna start rocking this one out real quick. Try to see how quickly I can get this one going. I think I might need to queue up some new music though. Oh yeah, literally 1 minute left on the music. All right, let's get this going. All right, here we go. Just gonna fly through this half since I've already done all the explaining here. kind of more of a full view of everything I'm doing. Oh, that does remind me. I forgot one thing on this one. That is silly of me. I forgot to add the battery connector. So this is a standard kind of like pH 2mm battery connector. Nothing too special. I'm just going to get that set up real quick. Get you out of the glare there. So first things first, I'm just going to do this real quick. This does have two metal contacts on the bottom. They're a little hard to see whenever you're actually like on the board itself. So just gonna liquefy it, move it in, and make sure those other two pins are lined up quite well. May need to be moved a little bit more. Get some of that extra gunk off. And there we go. I would say those pins are aligned. Yep, that looks like a positive connection for me. And I'm just going to get this last bit over here. Get you in shot there. All right, there we go. My apologies on that one. Totally forgot about the battery connector. Probably because it sticks out so much. But at that point, you would typically, I've got a pretty much dead area right here underneath this switch and everything else that you kind of put your battery. I think the battery that I typically have kind of set up in CAD to use are these, I think these are 70-20-30s. Yes, 70-20-30. So anything this size or smaller will work. And I do have that space on the board itself for adding those. So yeah, there we go. Moving that one over so I can keep working on this. Oh, I've picked up a stray. Let's get moving. Let's get this kind of moved back into shot here. Perfection. There we go. Yep, squeeze those to get a nice little area for you to come through and just get them out of there. And once again, just make sure that you are matching up the line on the diode itself with the line on the board over here. Oh, lost you. Where'd you go, guy? There we go. Oh, no escape. So close. Come on. All right. Oh, did I lose one? No, I guess that was one that was just sitting there. Bulk. Yeah, that's just. All right. Oh no. The end of days is upon us. That's a bummer. Guess what I'll do for the rest of this build is switch over to the harder to use solder. One trick that I am going to do is just feed it directly off the reel to do these, just because it's a lot easier that way since these use up so much solder. Bump this up here real quick to like 370. Get back in your home. Thank you. All right, other side. All right, all those are done. Let's not forget the caps while I'm here. There we go, I've got a few extra. Thank you, 4 over here. Uh-oh, that's not good. All right, well, time for some troubleshooting. I have accidentally filled up that hole right there. So we'll grab some solder wick, chop off a real tiny piece just so I can heat soak it. Grab with some tweezers. And get that solder off of there so I don't block that hole for the shift register. Looking good. Okay, cool. Crisis averted. Yeah, let's get the reset switch. Yeah, let's do this the other way. So I'll burn the ever-loving bejesus out of my fingers again. Wow, yeah, these look pretty straight out the box. So we'll probably take a little manipulation, but cross that bridge when we get there. Nope, almost had it. I go too far with one? No, maybe. There we go. That's seated. All right, there we go. All right, I think I need to go find my other box of Zows. I'll be right back. All right. That needs to be shifted way up. Still needs to be up a little bit more. Perfection. Yeah, this no wash rosin solder behaves very differently to my good stuff. And honestly, these don't get up to any temperature that leftover rosin even matters. That's only a problem in like high temp deployments when the leftover rosin resin can become caustic. In normal use of like a keyboard, I don't think that necessarily really matters. For some high signal integrity applications like electrocapacitive keyboards, like some of the ones that Pete from ZMK makes, yeah, that leftover rosin can, or flux residue can definitely cause some problems when it comes to signal integrity. But not for anything like this that is just reading up down states. This one's got some leftover ears on it. Just gonna take some clippers. All right. No, no, I moved it too quick. Make sure I didn't bridge anything. Yeah, it's pretty close. Let me just clean that up. Note to self, let the solder coalesce before moving it again. Excellent. That should do the trick. All right, and the final step. Let's turn this way. Uh-oh, bridge of those two. Don't want that happening. There we go. Nope, that didn't get it. All right, that does it. We've got two halves fully built. Not forgetting anything, am I? Does not look like it. All right, cool. Well, now all I got to do is make sure I get some functional batteries in for these, and I can start getting them fully assembled. So That pretty much wraps it up for the PCB assembly. Hopefully I'll get some extra cases printed out and get some of those VIK modules tested so I can have a stream where I just kind of assemble one from start to finish with keys and a case and everything. But that pretty much wraps it up for the build guide, and thank you for watching. Have a great day, everybody, and take it easy. Goodbye.